Okay, today we are doing lesson 4 and it is related to yesterday's. We've done similar stuff like this with the distributed property. So practicing and making sure we understand very well what we're doing. So part A, or A up at the top, this is similar to what we have done or what we did yesterday. So being able to multiply through. So 2x plus 10. The next one, 3 times x is 3x. 3 times 4 is 12. The next one, multiplying through, we have 6x plus 6. And then the next one, 7x minus 21. Now, on E through H, we're working backwards. So we're looking for what can go into both of those. So I have to think to myself, what can go into both 5x and 30? And some of you are going to go right off the bat and know that it's a 5. But I think to help with the understanding, I'm going to go over here and draw the model. And so this part right here is like what's in the box. So 5x and 30. And then we look at it and say, oh, well, 5 will go into that. So I work each section backwards. And so I have 5x. Well, 5 times what gives me that? 5 times x. And then 30's in the other box. Well, 5 times what gives me 30? 6. So over here in parentheses, I have x plus 6. So then what went on the top? Okay. So for the next one, I have 8x and 8. And I think to myself, what's going to go into both of those? 8 will. And then I work the area backwards. And so 8 times x gives me 8x. And 8 times 1 gives me 8. So the 8 goes here. And then in parentheses, x plus 1. Now on the next one, I'm going to go up here where I've got a little more room. I have 3x and I have 12. I think to myself, what goes into both of those? 3. 3 times x is 3x, and 3 times 4 is 12. So over here, 3 is on the outside. Now paying attention here, this one had subtraction. So I want to make sure I do x minus 4, not x plus 4. And then for the next one here, over here, 15x and 20. So I think to myself, 5 goes into both of those. 5 times 3x would give me 15x, and 5 times 4 would give me 20. 5 outside the parentheses, and then 15x, whoops, not 15x, let me fix that, 3x plus 4. Okay, now these models over here in these directions don't require it, but I think there are a lot of people that benefit from that, just seeing what it is, how we were coming up with it. But by no means are you required to draw out the area models unless they ask for them. Okay, so going on to the next section. So here, they're asking me to rewrite the expression as the product of two factors. So I think to myself, okay, here's my box, 72t and 8. What's going to go into both of them? 8. And then this would be 9t and 1. So this is equal to 8 times the sum of 9t plus 1. All right, on the next one, thinking to myself, what goes into both of them? 36. and then I divide them both by 36, and so the first term is going to be z, and the other one's going to be 2. For the next one, I can see that 3 will go into both of them, and then 3 times r is 3r, and 3 times s is 3s. On b, looking at those two terms, I know that 11 will go into both of them. So on the first one, 5a divided by 11 is 55a divided by 11 is 5a, and 11 divided by 11 is 1. On the next one, 144q minus 15. So something doesn't stick out at me right away, but I know 15 is not going to go into 144 because they both would have to be multiples of 5. 5's not going to work, so I'm going to check 3. I know 3 goes into 15, so I use my divisibility rule. 1 plus 4 is 9. 3 goes into 9, so 3 is going to go into 144. And then on this one, I'll take 144, divide it by 3. It's okay to go to your calculator to do that if you don't know it. And it is 48q. And then 15 divided by 3 is 5. Okay, go ahead and go to the next page. Okay, here you can see they're setting up the models. So on example 2, they've got the model set up. They're asking us to determine the length and the width of the rectangle. So I look at 2x, 12y, and 8, and I think to myself, what's the largest thing that'll go into both of them? Although 4 goes into both 12 and 8, it won't go into 2, so 2 is going to be the largest number I can use. And that gives me x there, 6y there, and 4 here. So 2 times x plus 6y plus 4. And these strategies are going to be really important in math next year. Okay. On the next one, the picture is done completely. It's just asking you to write the product and sum of the expressions being expressed in the rectangular array. And so we have 2 times 12d plus 4e plus 3 is equal to 24d plus 8e plus 6. And the reason we really work through to make sure we understand all these equivalent expressions is because there's going to be times where one form is better to use than the other. Okay, on B here, I asked us to factor out here. So we've got 3 terms, 48j, 60k, and 24. Now it doesn't require the model, it's just a good visual for people. So when I look at those 3 numbers and trying to decide what will go into both of them, I know that 12 will go into all of them, but I do a mental check real quick to see if 24 does, but it doesn't. So I use the 12. I get 4 and 5k. Whoops, I forgot my j there. And 2. So we end up with 12 times the sum of 4j plus 5k plus 2. Okay, on to the next page. Okay, on the next page, talking about opposite. So showing when something is the opposite. So remember our negative sign kind of works like an opposite. So it wants to know what is the opposite of negative 6v plus 1. So the opposite of that, well, I put my opposite sign out here. Now remember, when I put that opposite sign there, it's like there's a 1 there. So then I multiply through by negative 1. And when I do that, negative 1 times negative 6v is 6v, plus negative 1 times positive 1 is negative 1. All right. On the next one, it says to rewrite 5a minus difference of a minus 3b in standard form. So 5a minus, we're going to put that 1 there to help us with our understanding, parenthesis a minus 3b. So this goes back to the simplifying that we were doing earlier this week and even the week before. So I'm going to start out with rewriting my subtraction as addition. 5a plus negative 1 times a plus negative 3b. So now I can use my distributive property and multiply negative 1 through what's in the parentheses. So negative 1 times a makes that negative 1a plus negative 1 times negative 3b makes that a positive 3b. Now I can combine this term and this term together, but I cannot combine the other one with them because a's don't combine with b's. It's like apples and oranges. They're two different things. So 5a plus negative 1a is 4a plus 3b, and that is as simplified as we can make it. On the next one, it says expand them. That means change our subtraction to our addition, and then collect similar terms. So I have 2p plus negative 3q in the parentheses. So now that I've rewritten addition as subtraction, I'm going to multiply through. Negative 3 times 2p is negative 6p, plus a negative times a negative is positive, so I end up with 9q. P and q are different letters, so I cannot combine those terms, so that's my answer. On the next one, negative a minus, remember that's that 1 there, a minus b. So I'm going to rewrite my subtraction as addition. Negative a plus a negative 1 times a plus negative b. So I multiply through with the negative 1. Alright, and if this helps, put that 1 there. So negative 1 times a is negative 1a plus negative 1 times negative b. Negative times a negative is positive, so I have 1b. Okay, these two have a, so I can combine them. Negative 1a plus negative 1a is negative 2a plus 1b, or you can just write b. Having the 1 there or leaving it out will not make it right or wrong. They're equivalent. Okay, next page. Okay, so you're looking at your problem set here. I want to clarify directions in problems 1 and 2 to make sure you're understanding. So when I look at problem 1, 1 times 3 plus 7 times 3, it says to write each expression as the product of two factors. So that particular problem, you'll notice that the 3 is what's being repeated. So this is equal to 3 times the sum of 1 plus 7. Okay, so I'm factoring out. Now on problem 2 with the different parts, asking us to write it as the product of the sum of two factors. So 7 times 6 plus 3. Okay, all right, go ahead and continue on your own.